Hello everyone, my name is Ashley McCullough and I am a junior chemical engineering student here at West Virginia University. Over this past summer, I have been conducting research with the Control, Optimization, and Design for Energy and Sustainability Group, also known as the CODES Group, here at the university, working closely with Dr. Fernando Lima and PhD student Salorme Agblies of the Department of Chemical and Biomedical Engineering. My research revolves around the data mapping and integration of renewable energy for the eastern United States, and more specifically for the PJM region. This region is defined by the PJM Regional Transmission Organization, whose acronym comes from their oversee of Pennsylvania, New Jersey, and Maryland's metropolitan areas. Despite this name, however, the PJM region is comprised of over 13 states in the eastern U.S., as seen in Figure 1. West Virginia is encompassed within the PJM region, and is defined more clearly within the AP region as seen in Figure 2. As the necessity for renewable energy systems has become more apparent over the years, so has the realization that these systems must be optimized by location-specific weather and geological data if they have any chance of competing with the long-standing institution of petroleum-based energy consumption in the U.S. And given the development of environmental issues across the world, these renewable energy systems must start competing sooner rather than later. That's why this research aims to propose further integration of renewable resources in the PJM region, based on predicted fluctuations in weather patterns throughout the day. The best way to describe this summer's role in the project would refer to it as creating the foundation for a long-term program that may outlast the duration of the SURE program. Because of this, the focus over these past 8 weeks was directed toward creating a self-sufficient system of code that continuously downloads PJM regional data and sends it to software that allows it to be plotted, observed, and analyzed over a long period of time. To do this, PJM data was downloaded for the following 5 categories: wind generation, wind forecast, solar forecast, and load. Each of these datasets is updated in 5-minute intervals, which is useful in our efforts to study changing weather data over the span of a typical day. MATLAB coding software was utilized in this data download, and such data was accessed using Web Application Interface calls, which are more commonly known as API calls. API calls simply tell the coding software what data needs to be downloaded, and a request, along with a key that is specific to the data we want to access, is sent to the web server of interest to be completed. Once the portion of code was written for this data download, code was then written to establish a connection between and send data to our group's OSI Pi database, using Pi's software development kit. Pi stands for OSI's Process Information Software, which is known for its ability to store and plot data in both industrial and research scenarios. Our final findings show that the code has been successful in downloading new data in the previously mentioned categories every 5 minutes, and has been running consistently and independently. Examples of the data being collected may be seen in Figures 3, 4, and 5, which showcase 3 days' worth of data to give a better understanding of the fluctuations in weather and demand throughout the day. This work enables the use of renewable energy data in the analysis and optimization of energy systems, and allows predictions to be made based on observed patterns and relevant inputs. While it's too early in the data collection to speculate expected results and how much of a region's energy makeup could be recommended for renewable energy, it is clear that future work of this project will take into consideration feasibility of these resources along with power generation. Feasibility may be based on a number of factors, one of which that has been discussed by our group is whether or not power plants for the resource in question exist in the area being observed. Examples of this include the fact that West Virginia doesn't have any solar farms at this time, so this would need to be taken into consideration when looking at solar potential in that state. Major limitations to the project are seen in PJM's inability to disclose utilities' locational information due to potential security issues surrounding renewable energy in the U.S. As a result of this, load data was the only data set that was able to be reduced in area, while all solar and wind data had to be looked at system-wide for the region. Overall, more specific recommendations for integration will be addressed and fashioned as more data is collected by MATLAB and written to the Pi system. I want to give a special thanks to the SURE program, Office of Undergraduate Research, and the CODES Research Group for their help on this project. Thank you all for your time, and please leave any questions that you have.